This podcast is on putting the equation of a circle in standard form and then graphing it. Down here in my example problem, you see the equation of a circle in general form and you see, boy, that is really a complicated equation. And trying to graph something from that would just absolutely be murder. But if I can get it in a standard form of a circle, which is this form here, x minus h squared plus y minus k squared equals r squared, then hk, this number comma this number, is the center of the circle, and if I take the square root of r squared I get r, which would be the radius. Now imagine if I knew the center and I knew the radius. If I had a graph here and say I knew the center was here and I knew the radius was that long, then I would just put that radius around there and bingo, I'd be finished with my graph. And that would be really easy and I wouldn't have to deal with this monster formula. So our job is going to be to get this ugly equation into this very neat standard form. Now notice that this neat standard form has a perfect square in x, then it has a perfect square in y, and then a constant on the other side. So this is going to involve completing the square. And if you've forgotten how to complete the square, you need to go back and review that on the video on completing the square. Now notice that if I was to square this x minus h, my first term would be x squared. Down here my first term is 2x squared. I don't need that 2. Same thing over here. If I squared this y minus k, I would get y squared, not 2y squared. So the first thing I want to do is get rid of those 2's. And I'm going to do that by dividing every term on both sides by 2. Now there's 5 terms on the left, 1 on the right, so that's 6 times here I'm going to be dividing by 2. So 2x squared over 2 is x squared. 2y squared over 2 is y squared. Negative 5x over 2 is negative 5 halves x, plus 6y over 2 is plus 3y. Negative 5 halves over 2 is negative 5 fourths, and 0 over 2 is still 0. So now I've got x squared and y squared. 1, that's what we want when we're doing completing the square. Now if I'm going to complete the square in x, I need my x terms together, so I'll write this as x squared minus 5 halves x. If I want to complete the square in y, I'm going to need my y terms together, y squared plus 3y, and I move my constant to the other side. Now it's time to complete the square, and remember what square we're trying to complete. The way you figure out the square you're trying to complete is you look at this second number, the number that multiplies x, not x squared. And that number is negative 5 halves. If I cut that in half, it's negative 5 fourths. So my perfect square in x is going to be x minus 5 fourths squared. And when I square that, I'm going to get x squared minus 5 halves x plus, and then I'm going to get a number that I get when I FOIL x minus 5 fourths times x minus 5 fourths. And when I FOIL that, this last term is going to be negative 5 fourths times negative 5 fourths, which is plus 25 sixteenths. Now I don't have a plus 25 sixteenths here. So right now I do not have a perfect square here, but I'm going to try to get a 25 sixteenths there, so that we do have a perfect square. Now let's take a look at what the y perfect square would look like. Again, I go to the y term, not the y squared term, and I cut its coefficient in half. That would be 3 halves, so y plus 3 halves is going to be my second perfect square. And when I square that, I'm going to get y squared plus 3y, and just as I did before, plus 9 fourths. I don't have a plus 9 fourths there. So what I'm going to do now is rewrite this as a perfect square. So instead of just having x squared minus 5 halves x, to get my perfect square I'll have to say plus 25 sixteenths. And to get my perfect square in y, I'll say y squared plus 3y, but then I'll have to add that 9 fourths plus 9 fourths. Now notice up here I had that these two numbers were equal. I have now added 25 sixteenths to the left and I've added 9 fourths to the left. So if I want them to still be equal, I have to add 25 sixteenths to the right and 9 fourths to the right. And that would give me, because this is my first perfect square, this would give me x minus 5/4 squared. Well, that's what I wanted, x minus h squared, where h is 5/4. Now I go to my second perfect square. This would give me plus y plus 3/2 squared. And on the other side, I need to get 16ths for common denominator so I can add this up. So I call this 20/16 plus 25/16 plus, and then multiplying this by 4/4, 36/16, which is a total of 81/16 or 9/4 squared. So my r is going to be 9/4. So I have x minus h 5/4. If you put this in the y minus k form, this would say y minus negative 3/2. So my k is actually going to be negative 3/2. So h is 5/4, k is negative 3/2, negative 1.5, and r is 9/4. 9/4 is the same as 2 1/4. So I come over here and I know that my x is 1 1/4. So I'm going to move 1 1/4 units this way, and my y is negative 1.5. So I'm going to go 1.5 units down. So that's going to put a dot. It's going to put a dot right there. Now I know that my radius is 2 1/4. So I have to come out 1, 2, and another 4th here. I'm down 1.5. So if I come up to here, that's 1.5. If I go another 3/4, that's 2 1/4 there. I'm 1 1/4 here, so if I come over here and then one more unit, that's 2 1/4 there, and then I go down 2 1/4, 1, 2, and a little bit more. And if I just draw a circle through there, there's my graphed circle, and that completes the podcast on graphing a circle.